This is lesson 13.1, multiplying polynomials. To warm up, let's talk about some things that you've already learned about multiplying using exponents. So remember that exponents are a shortcut way to write multiplication. So if I have m times m times m times m, a shortcut way to write that is m to the fourth power, and then n times n is n to the second power. So that's how I would write my answer using exponents. Number 2, it says write without exponents. So this is called expanding. So to expand a polynomial, you would write it the long way. So r to the second power is r times r, and then v to the sixth is v times v times v times v times v times v. 1, 2, 3, 4, 5, 6. Okay, and then times w, and then x to the third. And that's an expanded version of that polynomial. So obviously we're very glad that we have exponents because we don't have to write all of those things out. However, knowing that you can is very helpful. Okay, now 3 and 4 are a couple of review type questions that are super important to understand. So number 3, it says, what is x plus x? So if you have an apple and you put them together, what do you have? You have 2 apples. And so this is going to be 2x. It's not x to the second power. If you have an apple, you don't have apple squares. Okay? Now on the other hand, if we have x times x, if I have something that measures x on one side and x on the other side, then I have x to the second power. So when you're multiplying, that's when you use exponents. When you're adding or subtracting, you are not changing exponents at all. Okay, so some properties of exponents. These are things that we need to know. So a couple of words. So when I say the base of an exponent, it's the factor that's in common. So for example, 5 to the third power, 5 is the base because 5 is the factor that's in common. So 5 times 5 times 5 is what that is. So that's the base. The exponent tells us how many times the base is used as a factor. So for 5 to the third, 3 would be the exponent. It's also known as the power. Okay, so some properties of exponents. Just so you know, I'm not a huge fan of memorizing this. And as I go through the problems and the examples, I'll refer back to these properties, but this is not something I want you to memorize. I want you to understand it instead. And that's because I feel like if you memorize it, it's great as long as you remember. But as soon as you forget how to, what the formula is or whatever, then all of a sudden you don't know what to do. So I'm not even going to go over that right now. We'll discover those as we talk about them. Okay, the next thing we're going to talk about real quickly is negative exponents. Now you've seen negative exponents before when you've done scientific notation, like 5.1 times 10 to the negative third. And what that means is, it means you're going to take the decimal and move it 3 places to the left. So basically you're multiplying by 1 over 1,000 is what you're doing. So negative exponents, the way we deal with them when we're multiplying polynomials is you look at it kind of as a red flag. So a red flag is like a warning. It's just kind of a signal that our base is in the wrong location. So if we're talking about a fraction, if a number has a negative exponent and it's in the numerator, it means this actually goes in the denominator. So we'll talk about that as we do a lot of these examples. So the next bullet point, it says when you move your negative exponent to the correct place, then the red flag or the negative or the warning is no longer needed. So here's some examples. So if I have 5 to the negative second power, that's really over a 1. So the negative is telling me it's in the wrong place. So I'm going to move it to the right place. So I'm going to move it to the denominator. And I do not need a negative anymore. So you'll notice that it does not have a negative in front. There's no negative. The negative is just telling us where to locate it. But once I've done the locating, then I'm done with the negative. 4 over m to the negative third. The negative 3 tells me that the m to the third is really needing to go in the numerator part. So once I move it up to the top, I don't have a negative anymore. Okay, so I've got a couple of other examples for you to look at. And you notice that like x to the negative fifth, that's going to move down. C to the negative second, it's going to move up. So basically everybody's switching places. On this last example I have here, I want you to notice what has the negative power. 5 does not have the negative power. R has the negative power. Okay, 3 doesn't have a negative power. V doesn't have a negative power. So R is the only thing that's going to move. And so that's something to keep in mind as we do these other examples today. Okay, so on the lesson, we're going to start out by using laws of exponents or properties, and this is what I was referring to on the previous page that I don't really want you to memorize, I want you to understand. And so as we look at these first examples, I'm going to show you how to write it out or expand it, and that helps us understand what we're doing. So on number 1, 5x to the 7th times negative 4x to the 3rd, the way that I do that problem is I'm going to write 5, then x to the 7th. Now you're not always going to have to write this all out, okay, because it's kind of a pain. But for right now, we're going to write it out because it helps us understand what's happening. And so all of this is being multiplied together. So I'm going to say 5 times negative 4 is negative 20. And then I have x 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 of those, so it's going to be x to the 10th power. Okay, now if you look at that and you look at the problem, was there a way that you could have figured that out without writing that out the long way? So I want you to think about that. I'm not actually going to say, I want you to think about it. Okay, number 2. Before I do number 2, I'm going to talk about to the 0 power. And this is something we talked about earlier in the year, but if you have any number to the 0 power, it's equal to 1. And we talked earlier in the year about, the reasons why. So let me just kind of go over that really quickly. If I had like 2 to the 3rd power, that's 2 times 2 times 2. 2 to the 4th power is 2 times 2 times 2 times 2, obviously. 2 to the 2nd power is just 2 times 2. And then 2 to the 1st power is just 2. So what would 2 to the 0 power be? So if I follow the pattern, what's going to happen there? Okay, now you might say 0, but it's actually not. This right here is equal to 16. This is equal to 8. This is equal to 4. This is equal to 2. So look, if I'm going from 16 to 8 and 8 to 4 and 4 to 2, what's the pattern there? What's happening to go from 6 to 8? We're dividing by 2 every time. So if I continue that idea, 2 divided by 2 is actually not 0, it's 1. Now, as far as the negative exponents go, I can continue that pattern. What's 1 divided by 2? It's 1/2. And so that pattern actually continues, and that's actually why the negative exponents work the way they do and why a number to the 0 power is 1. It's not 0. Okay, so on number 2, I'm going to again expand this. And so I'm going to take this first term that's in parentheses, so negative 4 r s s s y y y times negative 6, and then r to the 5th, s to the 2nd, and then y to the 0 is just 1. So multiplying by 1 doesn't really do anything, so I don't really need to write it. And so I'm going to take the negative 4 times the negative 6 is 24. And then we're going to go in alphabetical order. So I'm going to say r, and I've got 1, 2, 3, 4, 5, 6 of them. And then s, 1, 2, 3, 4, 5 of them. And then y, 3 of them. So this is our final answer. That's our simplified polynomial. So you might need to pause this and stop and examine what's happening with everything. But as you're doing this and as you're discovering what's happening, go back to that page where I said, I don't want you to memorize it. I want you to understand it. And we're actually going to be, bringing those ideas in, but I'm not actually going to say it. So I want you to think about it. Okay, I'm going to erase this to make some room. So going to number 3, negative 2, x to the 2nd, y, z to the 3rd, but then it's in parentheses to the 4th power. What does that mean? That means that everything in the parentheses is going to be repeated 4 times, everything. So I'm going to have negative 2 times negative 2 times negative 2 times negative 2. I'm going to have x to the 2nd, but I'm going to have it 4 times. And then I'm going to have y 4 times. And I'm going to have z to the 3rd 4 times. And so this one's where you start to be really glad if you understand what's going on with the exponents, because it's a pain to write that out 12 times. Okay, but writing it out, then you start to understand, oh, that's why that works that way, because this is a different property. So if I do negative 2 times negative 2, that's 4, times negative 2 is negative 8, times negative 2 is positive 16. Then I'm going to have x to the 1, 2, 3, 4, 5, 6, 7, 8th power, y to the 1, 2, 3, 4, and z to the, count them out, you have 12 of them. Okay, so look at how that's different because it was raised to the power of 4 with the parentheses other than like when we had it without the parentheses? How is that different? Okay, so again, going back and looking at those properties on the previous page, I want you to look at that and understand why those rules are what they are. It's not just because somebody made them up. Okay, number 4, find the area of a triangle. So the area of a triangle is this formula. And so in this triangle, our base is 4a to the second c, and our height is this. So we're going to say 1/2 times 4a to the second c, and I'm going to write meters right there, times 6 AC to the third, and that's also in meters. Okay, so when I go to multiply this, I'm going to say half of 4. Half of 4 is 2. Okay, now I'm done with the half and the 4. And then I'm going to multiply by 6. And I'm going to have a to the second, c, and then a, and then c to the third, and then meters times meters. So when I simplify that, 2 times 6 is 12. A to the 1, 2, 3. C to the 1, 2, 3, 4, and then meters squared. And that's the area of that triangle. So what we're doing with this problem is we're taking the exact same type of math that we're doing, but we're putting it in the context of the area of a triangle. And I'm just erasing this to make room for the next problem. But we're just putting it in the context of something. Okay, number 5, we're doing a division problem. And remember, a fraction bar is just division. And so I'm going to write this out. The best way to do this kind of problem is actually not to use any properties, but actually to write it out. And there's a lot of applications for this as we move higher in math. But the best way that you can do this problem is take 12 and break it down. 12 is 2 times 6. And then m to the 8th, I'm going to write it out. Again, this helps us understand why the rules are what they are, instead of just saying, well, I don't remember what the rule is, because that's how I went through high school, is I just didn't remember the rules and I didn't know what to do. So trust me when I tell you that that's not a good plan. -3, I'm going to write that as -1 times 3. And we'll see the reason why in just a second. And then I'm going to write m to the second and then n to the fourth. And I'm going to kind of scoot that down there. You'll see why in just a second. Okay, the next thing that I'm going to do is now I'm going to go and cancel things, because things like 3 divided by 3, that's 1. M divided by m is 1. M divided by m is 1. N divided by n is 1. So what do I have left? On the top, I have 2 times 2. I have m to the 1, 2, 3, 4, 5, 6th power over -1 n to the 3rd power. And that's my answer. Now, some people ask the question, do I have to write the -1? You have to write the negative. You don't have to write the 1. So you could actually write your answer like this, negative and then 4m to the 6th over n to the 3rd. You could write the -4, m to the 6th over n to the 3rd. All of those would be fine. Okay, moving on to the next portion. I'm going to go through these, and at this point you might want to pause and maybe look at the written notes instead of watching the video, because it might enable you to kind of skip across to different questions that you have. And so you might want to try some of these on your own and then maybe check it with the written notes, or you're welcome to watch the whole video and go through every single problem. Okay, number 6. Again, I'm going to write out 5b to the 4th over 15 is 3 times 5, and then b. And so then what I do is I cancel 5 divided by 5 and b divided by b. So that's going to give me b to the 3rd over 3. Okay, number 7. Everything in here gets the power of 3. Okay? Now, when we're doing a problem like this, one thing that I like to compare it to is if you're having, let's say that your mom comes and says, hey, you get your brother's bedroom. And so, great, you get to move into your brother's bedroom. So do you pick up every single item one piece at a time and go put it in the room, like the trash and everything? Or do you gather it all and put it in a box and throw out the trash and clean it up and then move it? That's a more efficient way to do it. So I like to compare it to cleaning up the trash first before you start moving. So what I'm going to do is I'm going to concentrate on what's inside the parentheses, and I'm going to clean that up, simplify it as much as I can before I address the 3rd power. So right now I'm just focused on what's inside. So I'm going to write -4, so actually I'll do -1 times 2 times 2, so I'm breaking it down, and then m to the 5th over, and then 8 is 2 times 2 times 2, and then m to the 0 is just 1, and then n to the second power. So now let's see what I can do with that. I can say 2 divided by 2 and 2 divided by 2, and there's nothing else I can do. So I'm going to write that as negative 1 m to the 5th power over 2n to the second power. Okay, that's what's inside my parentheses now. So now it's time to take it to the 3rd power. So now it means everything in there gets written 3 times. So negative 1 times negative 1 times negative 1. Now m to the 5th, I don't want to write that expanded 3 times. I'm going to have m, 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 m. So you're going to have m to the 15th power, and that's where you start to really appreciate the properties. 2, I'm going to write that 3 times. So you do not want to do 2 times 3. That's not, or it's not, yeah, 2 times 3 is not what we have. We have 2 times 2 times 2, which is different. And then n to the second, you can write that out, or if you're starting to figure out how to do it without writing it out, that's fine too. And so what this gives us, it gives us negative 1 times negative 1 times negative 1, m to the 15th power over 8 n to the 6th power. And that is your final answer. Okay, number 8. Again, I've got this mess to clean up inside the parentheses before I deal with the exponent on the outside. And so I'm going to take care of what's inside there. So first I'm going to write 3 x to the 5th, y to the 2nd, and then z over 5. X to the 0 is just 1, y to the 3rd, and z to the 4th. Okay, so now I'm going to cancel what I can, and then I'm going to write it in a simplified version. So I'm going to have 3x to the 5th over 5yz to the 3rd. So that's what I have inside my parentheses now. And so let me just erase this to make room. And so now I'm going to take that to the 2nd power. So what does that mean? It means everything in there gets written 2 times. So 3 times 3. X to the 5th times x to the 5th. So if you think about it, I'm going to have 5 and 5. So I'm going to have 10 of them. And then 5 times 5, y times y, z to the 3rd, z to the 3rd, z to the 3rd. So what that simplifies down to is 3 times 3 is 9, x to the 5th times x to the 5th, 5 times 5, y times y, and then z to the 3rd, z to the 3rd, z to the 3rd. I've got 3, 3, and 3, so I've got 9 of them, so z to the 9th. And this is our final answer for number 8. Okay, number 9, 12, I'm going to write that as 2 times 6, so 2 times 2 times 3, m to the 8th, and then n, over negative 1 times 3. Now the reason why I do that is because if I kept it as negative 3, then it wouldn't cancel with that. So I need to separate out the negative. And then m to the 2nd, and then, oh, something new here, n to the negative 4th. My negative exponent tells me that that is in the wrong location, so I'm going to put it on top of the fraction n to the 4th. Okay, there's no negative that goes with it. It just means move it. So once you've moved it, then you've done what you need to do. Now I'm going to cancel what I can. So there's not a lot. And what do I have left? I have 2 times 2. And then m to the 1, 2, 3, 4, 5, 6. N to the 1, 2, 3, 4, 5. Over negative 1. So I could leave it like that, but really we don't really write things over 1 or negative 1, so you could just write negative 4m to the 6th, n to the 5th, because 4 divided by negative 1 is negative 4. Number 10, notice that b has the negative 4th power, but 5 does not. 5 actually is to the 1st power, and then b to the negative 4th power. So 5 is not going to move anywhere. So the way that I recommend handling these problems is start with a new fraction bar and just start writing things down. So when I write b to the negative 4th power, I'm going to be writing that down on the bottom because that negative 4 tells me to move it. And then on the bottom I've got 15, which is 3 times 5, and then I've got b. And so when I go to cancel things, the only thing that can cancel is the 5s. And so what do I have left? On the top, I don't have 0, I have 1. And you do have to write 1 if it's on the numerator. And on the bottom, I've got 3 and then b to the 5th. And that is the simplified version. Okay, number 11. Everything in here, this x to the 3rd, everything has a -2 power. So what that means is it means everything in here is in the wrong place. So one way I could look at that is I could say, well, I'm going to move that x to the 3rd to the bottom and then raise it to the 2nd power and do it like that. Okay, that's one way you can do it. You can also, if you're thinking about the properties from the previous page that maybe you figured out, you could use that property with the exponents. I'm just going to go ahead and just get my fraction bar and say I'm going to take x to the 3rd, but I'm going to put it on the bottom, and I'm going to do 2 of them. And so what do you have on the top? You don't just have nothingness, it's 1. So the answer is going to be 1 over x to the, think about it, you've got 1, 2, 3, 4, 5, 6. So x to the 6th power. Now another way to write that same thing would be x to the -6th. That's actually exactly the same thing, but it's actually not considered proper to write negative exponents as a final answer, so we usually don't write it like that. So I'm just going to say no right there, because I don't want you to write it like that. I want you to write it like that. Okay, number 12. Everything inside here has a -1 power, so that power goes to everything inside. So again, cleaning up the mess, I'm going to deal with what's inside first. So the 24, 3 times 8, and then m to the 5th. I'm just going to look at what's inside the parentheses before I do anything else. 8, and then m to the 7th. One way that I like to think about problems like this is I like to think, okay, where do I have more m's? Do I have more m's on the top or on the bottom? And you say, well, I have more on the bottom. How many more on the bottom do you have? You have 2 more. And so what that helps me do is it helps me understand that I'm going to have m to the 2nd as my denominator. So on the top, I'm going to have 3 over, and then I'm going to have m to the 2nd power. That's what's inside my parentheses. Okay, so I still am not done with this problem, but it's inside my parentheses, and now it's to the -1. Since everything in there is to the -1 power, means everything gets to switch places, m to the 2nd over 3. And that's my final answer. Okay, 13, there's a lot of negative exponents here. And so what I do is I start with a new fraction bar, and I just start writing. So a to the 5th, that's a +5, so I'm going to write it on the top. B to the -7th, because the negative, I'm going to write it on the bottom. C, I'm going to write it on top. And D to the 0 is just 1. I don't need to write that at all. Okay, on the bottom, the A to the -1, because of the -1, I'm going to move it. So I'm going to write it up there on top. C to the -5, because it's negative, I'm going to move it. So C to the 5th on the top. And then D to the 2nd, that one's on the bottom because it's to the +2, so it just stays where it is. Now I'm going to go and look and see if there's anything that I can simplify. All the A's and C's are on top, all the B's and D's are on the bottom, so there's nothing I can cancel. So I'm just going to write what I'm left with. I'm left with A to the 6th power, because I got this one also. And then C to the 5th, 6th power also, over B to the 7th, D to the 2nd, and that's my final answer. So again, it might be good for you to practice some of these problems just by doing them yourself and go back and comparing them maybe with the written notes. That might be more helpful. And then number 14, again, cleaning up everything that's inside of that. And let me clear out the writing on this. But I'm just going to deal with what's inside right now. I'm not going to worry about the exponent. So I'm going to say 3 and then x to the 5th, y to the -2nd, that means it's going to go down here, and then z. And in the 5 does not have a 0 exponent, only the x has a 0 exponent. So I'm not going to write anything for x. Y to the -3rd, that means I'm going to move it. And then z to the 4th, that's going to be on the bottom because it's got a 4, not a -4. So I'm going to see what I can simplify, and it looks like I can cancel a z. It looks like I can cancel some y's. So I'm going to have 3x to the 5th over 5z to the 3rd. Okay, that's what's inside my parentheses. So I'm going to have that, and now I'm going to raise it to the second power. So again, that means everything in there gets a second power. So that means 3 times 3. It means x to the 5th times x to the 5th. It means 5 times 5. It means z to the 3rd times z to the 3rd. So when I go and simplify that out, I'm going to have 9x to the 10th over 25z to the 6th. Okay, I'm going to do the last two questions on a different video, so you'll want to go to part 2 for this lesson and listen to that second video.